So today we are going to talk about how we graph quadratics without using a graphing calculator, okay? So we're going to be graphing quadratics, and we're going to be talking about graphing quadratics in vertex form. Okay, so every quadratic that we look at today is going to be in the form y equals a, and then in parentheses, x minus h squared plus k. So this is definitely a different version of looking at a quadratic than we've looked at before. Everything we've looked at up till this point, we've been looking at ax squared plus bx plus c. However, when we're in this form, we can graph a little bit easier and find information a little bit quicker. So just when we're working in this form for today, assume that anything that's in the form ax squared plus bx equals c, we could turn into this form. You don't need to know how to do that on your own. So there's some important information we need to know about this. Just like we talked about before, A is still going to identify if the parabola opens up or if the parabola opens down. So if A is positive, the parabola is going to open up. And if A is negative, the parabola is going to open down. Okay, that vertex that we talked about finding yesterday, which is that high point or the low point, the maximum or the minimum, we're going to be able to find by doing h, comma, k. Now, if we notice up here in the formula, h has a subtraction sign in front of it. So whenever we're pulling out h, we're going to have to take the opposite sign of what it looks like. So if it looks like a positive, we're going to use a negative. If it looks like a negative, we are going to use a positive. Okay, so we're taking the opposite sign of h. Then we also talked about how the vertex splits that quadratic directly in half, right? It goes right down the middle. That line directly down the middle is called the line of symmetry, okay? Or sometimes we call it the axis of symmetry. Okay, so the line of symmetry or the axis of symmetry, and I'm just going to sort of shorten the word symmetry, is always x equals, so no matter what, we're putting x equals, and then x equals h. Okay. So let's say I'm given the equation y equals x minus 3 squared plus 4. I would first want to decide what does A equal. So in this equation, A is what's sitting directly in front of the parentheses. So A equals positive 1. So if A is positive 1, is this parabola going to open up or is this parabola going to open down? We should have said that this parabola is going to open up. Whenever A is positive, we know it opens up. Okay, we are then going to find our h and our k, right? H comma k is what makes up our vertex. So our h value is always sitting here. It looks like a negative 3, but we are going to write it as the opposite sign, right? So our h is going to equal 3. Our k is always here at the end. Our k is going to equal 4. So if our vertex is h comma k, what is our vertex going to be for this parabola? We should have picked 3 comma 4 for our vertex. Okay, that's going to be the maximum or the minimum because it's h comma k. Now, our axis of symmetry, our line of symmetry, is the line that cuts the parabola in half, and it's always x equals h. So what is our axis going to be for this problem? We should have picked x equals 3, or x equals h, which is 3. Okay, this is the information that we need to then be able to graph this parabola. So if we decide from this information, we want to graph this parabola. Okay, I'm just going to create a quick coordinate plane here. We are first going to plot the point 3 comma 4. So I would just go on my coordinate plane to the ordered pair 3 comma 4. Now, this is just something you're going to want to write down in your notes. Okay. Whenever we find the other points of our parabola, it is always going to be over 1, so left 1, 1. Oops, I missed one. Left 2 and 4. Right 1 and 1. And right 2 and 4. So mine are 1 high because I forgot the first one, but that's fine. Okay, you'll just need to know these. So write them down in your notes and keep them. Those points tell us how much to move to get the rest of our parabola. Now, these numbers didn't appear from nowhere. This is a quadratic, so they are the numbers squared. 2 squared is 4. Right? Negative 2 squared is positive 4. They're just the numbers squared. 1 squared is 1. Negative 1 squared is 1. So since it's a quadratic, it's just each of those numbers squared. So what I'm going to do is from the point that I made, I know that I want my parabola to open up because A is positive. So this right column is going to tell me how many to move up. So from this point, I'm going to move left 2 and then up 1, 2, 3, 4. So left 2, up 4. Okay, then I'm going to go left 1, up 1, right? This is left 1, up 1. Again, from my vertex, now I'm going to go right 1, up 1. And from my vertex, I'm going to go right 2, up 4. And there is my parabola. So let's look at graphing another one here. Let's say we are given y equals negative x plus 2 squared minus 5. What does a equal for this parabola? We should have said a equals negative 1. Does that mean that this parabola will open up or will it open down? We should have picked that it will open down because a is negative. What does h equal for this parabola? We should have picked h equals negative 2 because we're always taking the opposite sign of what h equals. What does k equal for this parabola? We should have picked k equals negative 5 because the k stays as the same value. What will our vertex be for this parabola? We should have picked negative 2, negative 5 because the vertex is always h comma k. And finally, what will our axis of symmetry be for this parabola? We should have picked x equals negative 2 because the axis of symmetry is x equals 8. So if I wanted to graph this parabola on my coordinate plane, I would want to plot the point, actually make this line a little higher. I would want to plot the point negative 2, negative 5. That is my vertex. So I'm plotting that point right there. Then I'm using that same table that I had from the last page, the one I told you to keep in your notes. Okay, but now because A is negative 1, it's telling me how many to move down. So from my vertex, I'm going to go left 2, down 4. From my vertex, I'm going to go left 1, down 1. From my vertex, I'm going to go right 1, down 1. And from my vertex, I'm going to go right 2, down 4. And this is a pretty terrible looking picture down here, but that is my parabola. Now, I also want you to be able to identify key pieces or key parts of a parabola. Okay, I want you to know what those are if we're just looking at them on a graph. So I want to talk about key features of a parabola. So if we have a parabola, no matter where it's listed in the coordinate plane, let me draw that a little bit better. Okay, just by looking at a picture, we should be able to decide if the parabola opens up or down simply by looking at the picture. So does this parabola open up or does it open down? We should have picked up, right? It's opening up like a U. Okay, to find the axis of symmetry when we're given the graph, we want to look for where the very middle of this graph is. Okay, that line that cuts the parabola in half is the axis of symmetry. The easiest way to get that number is by finding the vertex first, because the axis of symmetry will go directly through the vertex. So if you name this point, right, the vertex when we name it is h comma k. So let's just say, let's make up that this is the point 3 comma negative 5. That would then mean that our axis of symmetry is x equals 3. So if you name the vertex first, you can just use that information to find the axis of symmetry. Okay, we also should be able to identify our x-intercepts. So what are x-intercepts? We should have said that x-intercepts are where a graph crosses the x-axis. We've already talked about this, and we already did this in Desmos. So our x-intercepts, or solutions, right, are where the parabola crosses the x-axis. And then finally, the last piece that we should be able to identify of a parabola are its y-intercepts. Okay, and the y-intercepts are where a graph crosses the y-axis. Okay, and there might be one place that it crosses on the x-axis, or two, or none, just like we've looked at before. So you're going to do an Alex assignment where you're going to practice identifying some of these features and knowing where those fall on our coordinate plane.